Okay, so now we want to assign our animations so that we can properly move our player around in the world and he'll actually look like he's doing some things. So what we want to do first of all is, now that we've finished dragging our sprites into our timeline down here, we can move our project tab back down to there like that, so that now we've got things a little bit more sensibly laid out and we can see things again. When we move that, we made some changes to the size of stuff, so we want to drag our inspector back in there like that, and we want to drag our hierarchy back over, so that we've still got plenty of space in our scene view and stuff like that here. Okay, so now we want to, like I said, we want to make some changes to our animation controller. So what we'll do is go up to Window here, and we're going to go down to Animator. And again, that'll open a new window, but we want that down here like this. Okay, so what we've got three different animations that we create on our player. We want to make sure actually that we stay selected on our player here. By default, it seems it's gone to that when we've opened it, but for example, if we were to click on something else, it'll stay open with all this stuff here, but if there was another animator that was active on something else, we'd move to that animator. So we want to make sure that we always stay on the active object that we're working on. Okay, so we've got our three different animation states here. We've got our walking, jumping, and our standing still. So what we're going to do is, first of all, we're just going to lay these out a little bit better. So I'm going to pull this walk over to the right here. We're going to put our idle up here, and we're going to put the jump down here. So at the moment, by default, because it was the first one we created, our walk animation is playing straight away. So that doesn't really make sense. So what we want is, when our player starts the game, we want them to be standing still. So what we're going to do is right click on our player idle, and we're going to set that as the default layer state. So the general basics of the animator here, these, like I said, these are the animations that we created, and we're going to work out now how to move between these animations so that we can make changes within our script, that we can tell the animator to change animations at the appropriate time. So for example, when we go from standing still to moving, and when we go to jumping into the air. So to be able to do that, we'll have to use some values that we can use. So if we click on parameters here, and we hit this little plus symbol, what we're going to add is, we want to know if the player, how fast the player is moving, basically. So we need to know if he's not moving at all, or if he is moving, then we'll start walking. And we also need to know basically whether the player is on the ground or not, and that's something that we added in the last couple of videos ago. We added the ability to check whether we're on the ground. So we want to be able to know whether we're on the ground, so that we know whether the player should be in his jump animation when he's in the air, or doing something else when he's on the ground. So we're going to add two little parameters here. So first of all, we're going to add a float, and we're going to call this speed. So this will be how fast the player is moving. And then we're going to go down here and add a bool. And again, a bool is just a true or a false variable, so it can either be true or false. And we're going to call this grounded, and that will be used to check whether the player is on the ground. Okay, so now that we have these two variables, we can set up how our animations will work with each other. And the way we do that is we'll right click on player idle here, and we're going to say make transition. And what that does is create this little arrow that we can drag around, and we want to click onto player walk, and that creates a link between those. So if we click on the link between them, if we just let it, there we go, it didn't come up for a second there, but we have all these options now of what happens when we create a link between them. So most important is our conditions down here. So these are the conditions of when will this kind of transition occur. So if we hit this little plus symbol, what we want to say is, if the speed, by default we get speed selected, but we can also go for grounded here if we wanted to. But so what we want to say is, if the speed is greater than, we'll say just 0.1. So if the speed is greater than 0.1, then we will go to the walking animation. And we can see a little preview down here. If we hit play, it'll just kind of show the new animation, basically, is what it goes to. We can do the same going back from our walk animation. So if we right click on walk and hit make transition again, back to player idle, we can do the same thing with our conditions. We can say when our speed this time is less than 0.1. So now when our speed goes below that, then we'll know that our player should be standing still. It'd be very hard to see a difference between when our speed is anything above 0.1 and 0, but just on the off chance maybe we might get a fraction of a second of a player kind of sliding a little bit when they look like they're standing still, and that can actually add to the game and make it look like they're kind of skidding a little bit. So you could even increase this value if you wanted to, but it's all up to you and how you want your game to work. So that's fine. And then we're going to look at what all this other stuff is in a minute, but we just want to set up our transitions first. So we're transitioning between both of those things, but then from whether we're standing still or whether we're walking, we want the ability to jump straight away from between those two things. So we want to say on our player idle here, we'll make a transition to player jump, and we will set on that the condition that if grounded is false, so if we're no longer on the ground, that means we must be jumping. So then we can go from standing still to jumping, but we also want to go from running to jumping. So we'll do the same thing, and we'll set when grounded is false, then we're jumping. But if we stop jumping, we know that we're always going to stop jumping by hitting the ground. And it doesn't really matter too much whether we send this back to idle or walk, because either way, if we send it back to idle, then it'll go, okay, we're idle, are we moving at all? If so, we'll go to walk. And the same, if we go back to walk, and it'll go, are we moving? If not, we'll go back to idle. So what we're going to do is only make one transition out of this, back to idle, and we're going to set this one to be if grounded is true. And the reason we only want to make one as well is because we're only checking if the grounded is true. If grounded is true and we were to make a transition back to both of these guys, then it wouldn't know which one to go to basically, and we could end up with some errors occurring. And we don't want that to happen, so we want to make sure that we're just going out one way. Okay, so now we've got all our transitions set up. Let's have a look at what this stuff is up here. So we've got a little thing that says has an exit time, and if we drop the settings down here, by default exit time is 0, and that's fine, but we've got a fixed duration and a transition duration, and these are all things that we don't want on our animation transitions. Basically, because we're using sprite based animations, we want it to instantly go from our player standing still to our player walking, whereas if you were using, say, a fully 3D model character, you want it to go from standing still to, you want it gradually to move into the first position where the walking animation is occurring, because your walking animation will be done in a loop, and if you were standing still and then suddenly clicking into a walking animation, that doesn't make sense with a 3D model, but it makes a lot of sense when we're using sprite animation like we are here. So what we want to do is make sure our transition duration here goes down to 0. So we want to set that on all of them, and we'll do that in a second. But the other thing we have here is a fixed duration, and basically what that means is the animation that this connection is going towards. So here, the player idle, it'll only it's telling that animation that it should only last a certain amount of time before moving on to another animation. And because we haven't set it up so that this animation knows where to go, we're going to start creating errors and stuff that we don't want. So what we want to do is turn off our fixed duration, and we also don't want it to have an exit time, which is, an exit time is basically how long our transition should last, because that's no use to us. So we want to make sure that we turn that off, and we want to do the same for all the other connections as well. So we'll go through them and just turn off the checkboxes and set the duration to be 0. Unfortunately, we can't actually select a whole bunch of them at once and then do it. We have to manually go through each individual one like this and set them all to be 0. So that's basically it for our animation controller. It's all set up for us now. Of course, at the moment, we still haven't told, our script isn't telling our animation controller when to make changes to our what animations we're doing at the moment. So that's what we're going to take a look at doing in the next video. Okay, so now that we've set up our animator, we want to be able to tell the animator what to do. So let's go back to our project files, and we're going to go into our scripts, and we're going to make some changes to our player controller once again. So we'll open that up here, and we'll need to know what thing we're actually making changes to. So much like before when we had to get the rigid body here, so that we could make, if we go back to our player, so that we could make changes to this rigid body, we wanted this time be able to make changes to the animator here. So we'll go back into our script, and what we're going to say just like we had here, a private rigid body for my rigid body, what we're going to add in down here now is private animator, and we'll call this my anim. Just keep it nice and short with my anim. And then again, much like we did with the rigid body, in our little start loop function here, we're going to say my anim is equal to get component, and then in the sharp brackets we'll type in animator, so that it's getting the animator component for us, and we'll put our open and close brackets and hit our semicolon. So now it knows as soon as the game starts, it needs to get the animator component on that is already attached to the player, so that it knows what we're going to be making changes to. So now we already know that the velocity of the player is the speed that we're moving, so we know that we can set that to be the speed that we're using back here in our animator. And we also know, of course, that on our is grounded value that we're using to determine whether we're on the ground or not, we already know that's a true or false statement, so we can also just send that straight to the animator. And the way we do both of those things, after all our inputs and stuff have been taken, so that we know that we're as up to date as possible with everything, we're just going to type in here my anim. So that's the animator that we know we've created back up here. So my anim dot set float. So we're setting the float value, which is our speed back here is a float, we know that. So my anim dot set float, and then we open a bracket. And again, if we look at our little tooltip thing down here, we've got a few different options again if we go down through all of them, but we're just using the most basic one, the first one here. So we need a string name and we need a float value. So our string name, much like we said here when we wanted to use the horizontal axis, we had to use these quotation marks to make it a string. And I'm not sure if I fully explained that at the time or not, but a string is basically just a collection of letters and numbers that make up a string of letters to make a word or a sentence, or it could just be a single standalone thing or anything like that. But in this case, the string we're referring to is the name of the parameter for our float. So that's our speed down here. So again, we want to put a quotation mark, and we want to type in speed and put another quotation mark to close it. And then we'll hit a comma, because we know we have another value that we want to put in. And if we look at our little tooltip, we've got a float value, which is what we want to set as the value of speed here. And we know that what we're talking about is the velocity of the rigid body. Now, the only difference with what we're doing here is, rather than just sending out the velocity of the rigid body, we want to make sure that it's only a positive number, because our move speed, which is what we're setting the speed of the player could be either, what is our move speed we have on the player? We set it to be 5, didn't we? Yes, 5. So the move speed could be either 5, 0, or -5. But back in our animator here, what we've set it up as is, if the speed is greater than 0.1, then we start walking. But if the speed is less than 0.1, we go back to our idle animation. But we don't want our speed to be, if we're moving to the left, our speed is -5. So that's less than 0.1, obviously. So we don't want, when we're moving to the left, our player to be all of a sudden only standing still whenever we move to the left and running whenever we go to the right. So what we want to do back in our script here, rather than just setting out the saying my rigid body dot velocity dot x, which would be the speed of whether we're moving left and right, what we want to do is put in front of that, we want to say matf, which means mat function basically, and we want to say abs, like that, and we put a bracket and we put another bracket. And so what this we actually need 2 brackets here just at the end, because we want to close the original bracket that we opened, and we put our semicolon. Okay, and so what matf.abs does is it's saying it's doing a mat function, and abs is for absolute, and what we're doing is getting an absolute value. So what this does is, if this is -5, it'll return it as 5. It just turns any minus number into a positive number. That's basically the simple version of what it does. It's very straightforward, and it's a very handy and useful thing to use within Unity. It's just it's a nice one to try and remember, because it can come up and kind of save you in lots of situations. So we just want to say matf.abs, and we want to say my rigid body.velocity.x. So now we know that we're sending out to our speed float here the right value. So we also want to send out a value for a grounded, and this one is a little bit more straightforward, because we can just say my anim dot, this time we want to set a bool, so set bool, and then we open our bracket. Again, we have to type in the name of the value that we want to make changes to, which is our grounded one here. And it's always important to make sure that we keep the capitalization of the letters the exact same, and the spelling the exact same. It has to be the exact same as it is down here. If we were to use a small g here, for example, we're talking about something completely different then, and it doesn't know where to set this bool value. So we want to make sure it's a capital G like that. And then again, we want to put a comma. And this time we don't need to make any changes to the value that we're sending in. We're just sending in, this is grounded boolean here, just straight as it is. So we just need to type in is grounded. And then close that bracket and hit our semicolon again to end the line. So now we can just save that, and we can pop back in here. And when this compiles down in the corner, what we should see is, well, we shouldn't see anything actually, but what we can do is, if we keep our animator window open here, when we start moving in the game, we should see our animations take place, but we'll also see our speed value changing here, and grounded ticking and unticking depending whether we're on the ground. So let's hit play here now, and hopefully, if we're doing everything properly, everything should be working just fine. Okay, so now we can see we've got our grounded turned on, our player idle here. We see this bar repeatedly playing like this basically means that this is the active component at the moment. So if we start walking, we can see it switches to being just like that. And if we jump now, we can jump in the air, and we see our animation turns to the jumping animation. We see everything is working just the way we want to, and grounded is turning off. We see our speed changing as we're moving. And like I said, whether we're moving left or right, we see speed is always 5. So we know it's a positive value, so we know we're doing everything just the way we want to. The only thing that's kind of looking a little bit weird at the moment is that our player, no matter whether we're moving left or right, he's facing the same direction. And that kind of looks a little bit weird and strange. So what we want to do is, we want to be able to flip the player around when he's facing a different direction. So that's what we're going to do next. Okay, so now that we've got our animator all sorted and everything with our animations is working fine, we don't need to worry about that anymore, so we can just go back to our project folder so we can have that open if we need to look at some more stuff. But, like we said, our player at the moment, when we're moving around in the world, is only facing one direction, which is, it's not very interesting. It doesn't make a lot of sense for what our player is doing. Unless you want your player to be moonwalking around the world, we probably don't want this happening. So we're going to need to make a few very simple changes to our player script. But before we make those changes, we're just going to show an example of what we're going to do. So if we look at our player here, like I said before, we've got a position, a rotation, and a scale. And our position obviously records where we are in the world. Our rotation records which kind of way we're facing, so we could spin that around and our player will flop around like that. Not very useful, but that's okay. And we have our scale, which controls whether we're big and stuff like that. So we have all these positive numbers making our player bigger, but if we scale ourselves down to a minus value, suddenly our player gets flipped over. It's hard to tell with this sprite in particular because of the fact that it looks the exact same either way. So actually we'll just go to our art folder and we'll just change the default sprites we're using for the player here. So we'll just drag the sprite 20 here. We'll drag that into the slot for our sprite, which is attached to our player. So now we're facing to the right like that. And if we grab our scale this time and pull it in, we can see that now the player is facing to the left if we're using a minus value. So that's basically what we're going to use to control whether the player is facing left or right. So if we go into our script here, we know that we're only going to change which direction we're facing based off whether we input moving left and right. So now we can just use that to set the scale of the player and control whether he's facing left or right. So in this first one here, where we're moving to the right, we know that we want our player to be facing to the right, and by default our player already is facing to the right. So we want to make sure that if we go sorry, not my rigid, if we just say transform dot local scale. So as I said before, every object within Unity has a transform attached to it. So that's why, rather than when we had to look for the rigid body and we had to assign it up here, when we look for transform, we don't have to look for that because every object already has that. So Unity knows if we just type in transform.local scale, what we're talking about is the transform, and specifically the local scale that is on the same object that this script is attached to. So we know our player controller script is only attached to our player, so we know that it's only talking about the scale of the player here. So like I said, we know that if we're facing right, we want it to look basically like it does in the game right now. So when it's set like it looks in the game right now, we can see the scale is the X is 1, the Y is 1, and the Z is 1. So we just want it to be set to be exactly that. So we want to say transform.local scale is equal to new vector tree, and then in the bracket we want to say 1F, 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 and 1F is for one float. So we're saying it's a float value, not an int value. So again, we're not creating any kind of confusion between those two different values. So we'll hit our semicolon there as well. And the reason we want to make sure that we're setting this to be the default number rather than just going with it as it is because if we go and set ourselves to be facing left, then we want to be able to go back to being facing right like this. So we're going to do basically the exact same thing here now when we're facing left, which is when our horizontal axis is less than 0. And we're going to say here our transform dot local scale is equal to new vector tree again, and this time we're going to say minus 1F. So it's exactly the same size but just flipped over backwards. So we'll say minus 1F, and then again we want our Y height to be the exact same. We don't want them to be upside down or anything like that, and we want to set our Z value to be the exact same as well because we're not messing with the Z value. As discussed before, we're working in 2D, so we just want to always keep the Z value being whatever it is by default. So it's by default it's 1 here, so we just want to leave that at 1 and not worry too much about it. So if we just save that by hitting Control and S, if we look back up here, this is why we want to make sure that we're explicitly saying this should be like this, is because if we move left first, then we're facing with our minus 1F, and we want to make sure we can go back to facing right by doing a positive 1F. So now we've saved that, and we'll go back in here. And again, it's a very straightforward and simple thing, but it makes a big difference to your game, obviously, because you want your player, whoever's playing the game, to get the direct feedback of knowing which way you're facing. So if we hit play now, with all those changes made, we can move to the right, and then we can move back to the left, and we see, just very quickly moving between them, we'll actually just right click here and maximize the screen so we can see it a little bit better. But we can see our player moves around just like that, and so all our animations by default are flipped around. So we don't need to worry about making specific animations for facing different directions. Now that we've just made the whole scale of the whole player just flipped around, what that does is it means all the animations are still intact, but now our player is able to just look like he's facing in different directions. So it saves us having to make twice as many animations in a very simple way. So there you go, that's the basics of all our animations set up nicely for us. Now that we can move our player around in the world like this, we need a way to be actually able to see some more of the world, because at the moment we can run off to the side like this. So we need to make sure that our camera can start moving.